Okay guys, so remember how last time we created that beautiful unit circle? Well, that's right above us, so we are going to use the unit circle today. We're going to use it to evaluate the 6 trig functions that we learned in chapter 9.1. Sine, cosine, tangent, cosecant, secant, and cotangent. So if you remember, on the unit circle, we can draw, if we start here, right, and we can draw an angle and land anywhere on the unit circle. So your book, I stole this from your book, they decided they were going to land in this 3rd quadrant here. Okay, so watch what I'm going to do. This is kind of a small drawing, right? So if I land here, I'm at some point on the circle x comma y. So watch what I'm going to do, guys. I'm going to draw this triangle right here, and I'm going to bring it down here so it's a little bit bigger. So this is 90 degrees, so I'm trying to draw exactly here. Okay, so the cool thing is, even though the angle theta is outside here, we can actually find the 6 trig functions. The angle theta on the outside is actually going to be the same. I'm going to get the same 6 trig function values if I use what's called, this is called the reference angle. So if I take this triangle and I enlarge it, I know here if I start at the origin, if I'm going to go to the left, that's going to be whatever the x direction. I'm going to go x to the left and y down, right? So let's go back to SOHCAHTOA. If I go back to SOHCAHTOA, I know that sine of any angle, this one's theta, is equal to the opposite over the hypotenuse. Okay, so let's think about this. Theta is here. The opposite side, we know our radius of our unit circle is 1, right? We learned that last time. So if I look here, this theta, the opposite over the hypotenuse is equal to the y coordinate over 1, which is just equal to y. Right? Now the cool thing is that means any point on this unit circle, I can find the sine of that angle by just identifying the y coordinate. Right? Okay, let's look at cosine. Cosine is equal to the adjacent over the hypotenuse. Okay, well let's look at theta. The adjacent side is x. The hypotenuse is 1. So our x coordinate on our unit circle, right, anywhere on the unit circle, is going to be the cosine. So here I've got the x coordinate. Okay, what about tangent? Tangent of any angle is the opposite over the adjacent. Okay, here's theta. Opposite is y, adjacent is x. Right? So the tangent is going to be equal to the y coordinate over the x coordinate. Or if we think of it in terms of the trig functions, it's equal to sine over cosine, y over x. Okay guys, remember the reciprocal trig functions. If I want to find the cosecant of an angle, what I'm going to do, sine, if I flip sine over, I'm going to get cosecant. So I can flip over the y coordinate to get cosecant. Or the y coordinate is the same thing as sine. Or you can think of it as 1 over y. Right? 1 over the y coordinate. Okay, secant is cosine flipped over. So what I'm going to do here is I'm going to flip over the x coordinate. Or in other words, flip over cosine. Or I can think of it as 1 over the x coordinate. And really that's sine. 1 over sine, 1 over x coordinate. Those are both the same thing. Okay guys, the last one is cotangent. So I'm going to flip over tangent, and if I flip over tangent, that gives me the x coordinate over the y coordinate. Which is cosine over sine. Okay, let's pause for a second just so you can just take a quick look at all of this. And unfortunately, I can't figure out how to pause while I erase. So if you guys want to fast forward through me erasing, that is fine. So I'm going to erase this. And we are now going to put this into practice. We are going to find trig values for particular spots on our unit circle. Okay, so the three angles they want us to find are, this is example 1, and it says evaluate the 6 trig functions. So they want us first to do pi, then they want us to do 135 degrees, and then they want us to do negative 150 degrees. Okay, so let me write these down. Sine, cosine, tangent, cosecant, secant, and cotangent. Okay, so first they want me to find the sine of pi. Well, let's pull down our unit circle and let's locate pi. So pi right here, guys, is at -1, 0. So what I'm going to do when I go to do my problem, I'm going to put the coordinates up here because it just makes it easier for me to see. So pi is at -1, 0. So there's my x coordinate and there's my y coordinate, right? So if I want to find the sine of pi is just the y coordinate. So in this case, the sine of pi is equal to the y coordinate, which is 0. Right? The cosine of pi is equal to the x coordinate, which in this case is -1. Okay, now we spice it up a little because the tangent is equal to the sine over the cosine. Or in other words, the y over the x. Well, that would give me 0 over -1. Okay, 0 over -1, we know anything, 0 divided by anything is 0. So let me put boxes around these. Okay, now we're getting into the reciprocal trig functions. So if you look at your notes, I can find cosecant by either flipping over the y coordinate or sine, or just putting 1 over that value. So cosecant of pi is equal to, well, sine is 0, so it's 1 over 0. But wait a minute, does that number exist? No. Can't divide by 0, so that one's undefined. Okay? Secant I can get by flipping over cosine, or in other words, 1 over cosine. So I can just say 1 over, let me write secant of pi. Secant of pi is equal to 1 over -1, which is -1. And our last one, cotangent, is equal to cosine over sine. Or in other words, x over y. Well, x over y gives me -1 over 0, which we know is also undefined. So there are the 6 trig functions of pi. Okay, now let's take another angle on our unit circle. We want 135 degrees. So let's find 135 degrees. Up here, 135 degrees is -√2 over 2, comma, +√2 over 2. So let's write that up there. -√2 over 2, comma, +√2 over 2. That's x and that's y, right? So let's find the sine of 135. The sine of 135 is the y coordinate. So that's root 2 over 2. The cosine of 135 is the x coordinate. And the x coordinate is negative root 2 over 2. Right? Okay, guys, tangent looks a little funny. Tangent of 135 is the y coordinate divided by the x coordinate. So that's root 2 over 2 divided by negative root 2 over 2. That looks so freaky until you realize that these are both root 2 over 2's. So anything divided by itself is 1, and this is positive and that's negative. So I just get a tangent of negative 1. Okay, guys, what about cosecant? Cosecant of 135, I'm going to flip over sine. So what happens if I flip over sine? Well, that becomes 2 over root 2. Right? But we can't have that. We have to get rid of that root on the bottom. So I got to multiply by root 2 over root 2. And that gives me 2 root 2 over 2. And what's that equal to, guys? Well, the 2's cancel, and I'm just left with root 2. Right? Okay, guys, secant 135, I can flip over cosine 135. So if I look at cosine 135, I can flip that over, negative 2 over root 2. Right? And I've already done this here, so that can just become negative root 2. Okay, guys, the last one, cotangent, is sine over cosine. Sorry, other way. Cosine over sine. Or in other words, x over y. So that's going to be negative root 2 over 2 divided by positive root 2 over 2. Right? And again, right here it looks kind of crazy, but really these are the same. So I'm just going to get, again, a negative 1. So that's what I've got for 135. The next one's a negative angle, right? So I have two options to find a negative angle. You guys can pick which one you like. The first is to start at my starting point, but instead of going up, that's positive angle, I can go down 150 degrees. So let's travel down 150 degrees. I've got 90, and then I need to go another 60. So it's going to land me right there, right, at 210 degrees. Another way to do it is to find a coterminal angle. You guys remember what coterminal angles are? I could just add 360 until I get somewhere along the unit circle, which is between 0 and 360. Notice I get 210 degrees either way, right? So let's look at 210 degrees. What are the coordinates of 210? Well, they're negative root 3 over 2, comma, negative 1/2. So let's write that down. Negative root 3 over 2. Oh, leave myself much room. Negative root 3 over 2, comma, negative 1/2. Okay, so the sine of negative 150, right, is equal to the x-coordinate, which in this case is negative root 3 over 2. The cosine of negative 150 is equal to, oops, sorry, I messed that one up, guys. Maybe I'm rushing. It's the y-coordinate. This is the x-coordinate. See, if one of you guys were here, you would have caught that. Okay, tangent of negative 150 is equal to the sine over the cosine. So that would be negative 1/2 divided by negative root 3 over 2. So guys, the cool thing is those both have a denominator of 2. So look, That goes out and that goes out. And I'm left with -1 over -√3, which is 1 over √3. But we can't leave it as 1 over √3, so we have to multiply it by √3 over 3. And that's going to give me √3 over 3. Is that visible? Right? Is that visible? √3 over 3?
Yeah.
Okay. Okay, now we go into the reciprocal trig functions. Let's do cosecant of -150. I'm going to flip over the sign coordinate. So if I flip over -1/2, I get -2 over 1, or -2. The secant, I'm going to flip over the cosine. If I flip over the cosine, I get that. But we know we can't leave the root on the bottom, so we have to multiply by √3 over √3. So that's going to give me -2√3 over 3. It doesn't matter if I put the negative down there or the negative up there. Okay, and the very last one, cotangent of -150. I'm going to take the tangent and I'm going to do x over y, flip that over. So that gives me -√3 over 2 divided by -1/2. Okay, so I get those, the 2's are out, and I get -√3 over -1, which is just √3. Okay guys, we are going to do a few more that are a little bit more spiced up, and then we'll be done. Okay, so turn your notes over to the other side. Okay, so the first thing they want us to do is they want us to find, now this time they're not asking us to do all 6 trig functions, just one. So they want us to find the tangent of 570 degrees. But wait, 570 degrees is not on the unit circle. This unit circle only goes from 0 to 360. But we learned 2 lessons ago that I can find an angle that's coterminal, right? Meaning it's going to be the exact same angle if I do an entire round around the circle. So 570 is bigger than the unit circle, right? It's bigger than 360. So what I'm going to do is I'm going to do 570 minus 360. And hopefully that will land me on the unit circle. And look, it does. So to find the tangent of 570, I'm going to use 210 as my angle. So if you remember from the problem before, 210 has the coordinates -√3 over 2, comma, -1/2. So if I want to find the tangent of 570, that's the same thing as the tangent of 210. Right? Because we just found a coterminal angle, and the tangent is equal to the y-coordinate over the x-coordinate. So the y-coordinate is -1/2, and the x-coordinate is -√3 over 2. So if I reduce that, that gives me -1 over -√3. Right? And I know here I have to multiply by √3 over √3, and that gives me √3 over 3. So that's the tangent of 570. Okay guys, what about the secant of -405 degrees? Well, that's definitely not on the unit circle, and it's smaller than 360. Right? It's small. So what I'm going to do, I'm going to find a coterminal angle okay, and I'm going to add 360 here because I want to get somewhere on the unit circle. So if I add 360, that's not enough, right? I need to add 360 because -405 plus 360 is still negative. So I need to add another 360. I could add as many 360s as I want, but my goal is to get somewhere between 0 and 360 degrees. So that gives me 315 degrees. So let's look at 315. Unit circle again. What are the coordinates at 315? Root 2 over 2, comma, negative root 2 over 2. So I'm going to write those down. Root 2 over 2, comma, negative root 2 over 2. And they want me to find the secant. So I can say the secant of negative 405 is the same as the secant of 315. Okay, what's the secant? The secant means I'm going to take the cosine and I'm going to flip it over. Flip over x coordinate. Okay, well the x coordinate is root 2 over 2. So I can say that's 2 over root 2. But we know that we have to multiply by root 2. So that gives me 2 root 2 over 2. Those go out and I'm just left with square root of 2. All right, guys, we're on this final stretch. Okay, let's look at this one. Now we're turning to radians, which I have to say is definitely harder. Okay, this is definitely harder. Now, if you look at your unit circle, you're going to see there is no 8 pi over 3, right? And the reason is an entire circle is equal to 2 pi. Right? And 8 pi over 3 is bigger than 2 pi. So what we need to do is, just like up here we subtracted 360, now we're going to have to subtract 3 pi. So I'm going to do, 2 pi. So I'm going to do 8 pi over 3 minus 2 pi. Okay, but wait a minute. How do I do that? Well, I got to get a common denominator, right, guys? I got to multiply this by 3 and this by 3. So that's going to be 8 pi over 3 minus 6 pi over 3, which is 2 pi over 3. So what I want to find here is cosecant of 8 pi over 3, which is the same thing as cosecant of 2 pi over 3. So look on your unit circle and see if you can find 2 pi over 3. 2 pi over 3 is up here, same thing as 120 degrees, negative 1/2, comma, root 3 over 2. So let's put that in here, negative 1/2, comma, root 3 over 2. Okay, and they want me to find the cosecant. So what am I going to do to find the cosecant? I'm going to take the y coordinate, I'm going to flip over sine. Okay, so if this is my y coordinate right here, if I flip that over, that's going to give me 2 over root 3. And we know that we have to multiply, we can't leave a square root on the bottom. So that's going to give me 2 root 3 over 3. Okay, guys, this is it, grand finale. Last one. D, they want me to find the cotangent. This is the most spiced up one. Okay, guys, that's a negative angle, so I know that I'm going to have to add 2 pi. I'm going to add 2 pi to try to get myself into the unit circle realm, which is somewhere between 0 and 2 pi. So I'm going to do 13 pi over 4 plus 2 pi. Okay, guys, again, we've got to get common denominator. So that's 13 pi over 4, negative 13 pi over 4 plus 8 pi over 4. You guys, look, we're still in negative territory. So what do we need to do? We need to add 2 pi again. Right? And we know 2 pi, we just found, is 8 pi over 4. So let's add 8 pi over 4 again, and that's going to get us to 3 pi over 4. Okay, phew. Now we're in the unit circle. So they want me to find the cotangent of negative 13 pi over 4, which is the same thing as the cotangent of 3 pi over 4. Well, what are the coordinates at 3 pi over 4? Let's check. Well, 3 pi over 4, the coordinates are negative root 2 over 2, comma, root 2 over 2. And they want the cotangent. I'm going to scooch this up a little. They want the cotangent, and my coordinates are negative root 2 over 2, comma, root 2 over 2. So the cotangent